Hi everyone, and welcome to BananaCode's free programming tutorials. Today we will discuss pointers and vectors in C++ and C++ exception handling programs. So before we start, make sure to watch the previous videos where I discuss some basic things related to this language. About today's topic, let's begin first with the C++ pointers. So the pointers are symbolic representations of addresses that are useful to create and manipulate the dynamic data structures. In other words, they are much similar to the arrays, and because of that, one of the main uses of pointers is usually iterating the elements of some array or modifying it. That's why you can see that the address of the variable you're working with is assigned to the pointer variable that points to the same data type, such as an int or string. Now let's get started with our first example. In this example, we need to enter n positive integers and also to enter the index from which we will start the summarization of the elements until the end of the array. Now let's begin with declaring and initializing the necessary variables. In this program I will declare the n variable, which represents the size of the array, then the integer array variable a with capacity of 100 elements, and the variable index, which represents the index that we start the summarization. After that, an integer pointer call pointer, which I will use to store the array. So as you can see, in order to declare a pointer you must first choose the data type, for this example an integer, and then you need to asterisk so that the program will notice that this is an integer pointer.
Now after I initialize this pointer with value of the integer array call a, I will initialize the n variable.
And then in a for loop I will use the pointer variable to fill the array with elements. So in order to fill the array through this pointer I need to increment every time I enter some element, because this pointer by default has the address of the first element, and every time I increment this pointer with the I variable, I am actually move the position of the pointer to next address, etc. Now we can create the sum_pos function that takes as parameters the pointer of the array, the size of the array, and the index from where the summarization should start. Now inside the function we will declare a new integer variable call sum, where we can store that summarization. And then in the for loop we increment the variable sum with every element which index position is greater or equal to the index value. After that, this function return that summarization. Now it only remains to call the sum_pos function and the value from that function to be stored in another integer variable, like for example res, that will be displayed with cout command. And now we can start testing this program. Now for n equal 5. We insert 5 elements 2, 3, 4, 5, 6, and if we insert for index variable 8, then we can see that the summarization is equal to 0 because the index variable is greater than the n variable. Now let's test this program again, but now for n equal to 4 we insert 4 elements 4, 5, 3, 2. And if we insert for index variable 1 we can see that the summarization is equal to 10 because we have made summarization of 5, 3, 2. Now let's begin with vectors in C++. Vectors are the same as dynamic arrays with the ability to resize themselves automatically when an element is inserted or deleted, with their storage being handled automatically by the container. Vector elements are placed in contiguous storage so that they can be accessed and traversed using iterators. Now let's begin with an example. Now in this example, we need to create a program that returns the elements of a vector that are strictly smaller than their adjacent left and right neighbors. To create a vector in the main function, first of all we need to include the library vector, which is a library that contains the vector data structure. And also many functions that are useful when we want to execute some operations within the vector. Now in the main function we will create a new integer vector call r, and then we need two integer variables, for example n and num. So the n variable will represent the capacity of the integer vector r. But the num variable will represent every number we input in the for loop iteration from 0 to n, and that number will be saved in the r vector by using the vector function pushback. After that we can create new vector function called test, and its parameter will be an integer vector. Inside that function we need to create a new integer vector that will store elements that are smaller than their left and right neighbor. Then inside a for loop we must insert a if condition that checks every element if they are fulfilling the condition of the task. If so, then we will store them in vector variable called temp and return that variable. After we have completed this function, now we need to store the value of that function in a new vector, for example result. Now it only remains to print all the elements that this vector result has. Okay, now let's test this program. For n equal to 5 we insert 5 elements 2, 3, 1, 4, 0. And as you can see, only the number 1 fulfills the condition of this example. Now let's continue with exceptions in C++. Exceptions are runtime anomalies or abnormal conditions that a program encounters during its execution. The process of handling these exceptions is called exception handling. In other words, an exception is an unexpected problem that arises during the execution of a program. Our program terminates suddenly with some errors/issues, and they occur during the running of the program, runtime. That is why C++ provides an inbuilt feature for exception handling. It can be done using the following specialized keywords: try, catch, and throw, with each having a different purpose. Now let's begin with an example. Now this example is very familiar and requires building a program that can handle division by 0. Now in the main function, I will declare two double variables call number and divider. And then I will initialize them with the sin command. Now I will create a Boolean function called checkDivider that checks if the value of the divider is 0 or not. Now in case the divider is 0, we need to use the keyword throw that will immediately terminates the current function and starts finding the matching catch block that handles the thrown exception. As you can see in this example, I will throw a runtime error, which is used when an error occurs that is related to the program's runtime environment, such as file input-output errors, logical errors, or violations of preconditions during execution. Now after we complete this function, now we can call this function inside a try block. Which is a block of code that may throw an exception. In case there is no exception, then we will calculate the result and print it. But in case there is an exception, then the program will automatically looking for a catch block. That is why we must insert a catch statement that can handle the exception. Now inside the catch statement, we need a new runtime error variable call mess that receive every thrown exception message. And then inside the catch block we print that message. Now let's test this program. It looks like I have made a mistake at the Boolean function that's supposed to return true instead of 0. Now let's try again. Now as you can see, for number equal to 34 and divider equal to 2, the result is 17. Now if we try again for number equal to 45 and divider equal to 0, then we will have a message that indicates that there is an exception. Now let's begin with more difficult exercises than the previous examples. Now the first exercise is to build a program that will transform an array of n elements in a way that the maximum and the minimum element swap their places and their difference to be added to the rest of the elements. So from the start, we need the n variable that represents the size of the array, then the integer array caller with 100 elements capacity. Now after we initialize both of these variables, we can now start creating a new void function called transform, and inside this function we will make every modifications. Now as you can see in this function I need two parameters. The first parameter is an integer pointer that points to the array and the second is the size of the array. So inside the function we need four variables and these are the max variable which represent the maximum value of the array, the min variable which represent the minimum value of the array, the max pos variable that has the index position of the greatest element and the min pos that has the index position of the smallest element. Now in for loop we need to make two if statements. The first one is to find the greatest elements by comparing the value of max with every element, and if there is an element bigger than max then eventually I will save the value and the index position of that element. The same goes with the second if conditional. After we find the greatest and smallest element, then we will swap their positions and in another for loop we will add the difference between the max and the min variable to rest of the element. Now after we finish this function now we call this function in the main function and then print the modified version of the array. Now let's test this program. So for n equal to 5, we insert 5 elements 12, 1, 5, 4, 2. And as you can see 12 and 1 have swapped their places and for the other elements was added the difference between 12 and 1 which is 11. Now let's continue with the second exercise. In this exercise, we need to build a program that can change the rows of two-dimensional vector with m and n dimensions based on the conditions above. Now in the main function, we need three integer variables num which represents the number we use to compare it with every element of the vector, n and m which are the dimensions of the vector. So after we initialize these variables now we will create that two-dimensional vector and initialize it. After that we need two for loops, and inside of the inner for loop we will check first if the element is bigger than num, and if so then the value of that element will be replaced with 1. Or else if num is equal to the element then the value of the element be 0, or else it will be -1 unless the element is bigger than num. Now it remains to print the modified version of this vector. Let's test this program. As you can see, this program prints the correct version of the vector. Now let's begin with the last exercise for today. In this exercise we enter some basic data for unlimited products such as name, barcode, price and discount until in the name of the product is written end. So in the main function, we need 2 string variables for name and barcode and 3 double variables for price discount and the total amount of all the products we need to pay. Because we don't know the number of the products we enter, we will create a do while loop, and inside we will initialize all the variables. But before we continue, let's not forget to put this in a try block. Now we need to create a new Boolean function called checkValid that needs to check if the barcode contains only 13 digits, and the name of the products does not contain digits. If so, then it will throw an exception with appropriate message. Now it remains to call that function, and if it returns true, then we can calculate the total amount, or else it will throw an exception. Because of that, we will create a catch block, and inside it will print every message from some exception. Now let's test this program. As you can see, this program prints every expected exception, and the total sum value is printed correctly. Okay everyone, so that is all for today. Thanks for watching. Don't forget to like, subscribe, and hit the notification bell for more tutorials. See you next time.